What it takes to save the axolotl. On the outskirts of Mexico City, biologists are working to reintroduce a treasured amphibian to the wild. But first they must revive an ancient method of farming. Xochimilco is a large, semi-rural district in the south of Mexico City, home to a vast network of canals surrounding farming plots called chinampas. Starting around AD 900, this maze of earth and water produced food for the Xochimilcas and Nahuatl-speaking people who were among the first to populate the region and engineer its wetlands. Nowadays in the early mornings, farmers, many of them descendants of Xochimilco's original inhabitants, can be seen loading canoes with lettuces and flowers grown in the rich sediments dredged from the canals. On weekends, hundreds of brightly colored party boats crowd the waters, full of urbanites seeking escape. The Mexican axolotl, a dusky amphibian with the remarkable habit of neoteny, or retaining its juvenile body type all its life, once thrived in these canals. Though axolotls have been reproduced widely as lab animals and in the aquarium trade, where they are more often pink or yellow thanks to genetic mutations, it is now questionable whether any significant wild population remains. At last count a decade ago, there were 35 axolotls per square kilometer in the Xochimilco wetlands, down from thousands in the 1990s. Pollution, urbanization and introduced fish species had made life nearly impossible for them. In the early 2000s, Luis Zambrano, an ecologist at the National Autonomous University of Mexico, or UNAM, was studying the effects of invasive carp when he was tapped by the government to survey axolotls. After decades of steady environmental degradation in Xochimilco, Mexico wanted to know how many axolotls remained in the species' last stronghold. Axolotls were of deep cultural importance, a feature of the region's traditional diet and cosmology. And laboratory biologists all over the world, who for more than a century had used axolotls to study tissue regeneration, worried that their animals were becoming inbred, without a wild population from which to draw new bloodlines. As an ecologist, Zambrano never entertained any strategy to save the axolotl that did not involve first restoring its habitat. But this isn't the middle of Borneo or the Great Plains of the Serengeti, he said. The habitat was Mexico City, population 22 million and growing. The number of factors counting against success was staggering. Springs that historically fed the Xochimilco wetlands were long ago diverted for urban use, replaced by treated wastewater. Introduced carp and tilapia ate axolotl eggs. New roads pushed urbanization ever further south, threatening the last remnants of the unique pre-Columbian farming culture whose canals had sheltered axolotls for over a millennium. Party boats not only brought noise and more pollution but tempted farmers to convert their chinampas to restaurants, bars and soccer fields and to let small canals dry up. Representations of axolotls occur everywhere in Mexico City. Their enigmatic faces grace street murals, handicrafts and even, lately, a 50-peso bill, but the animal's natural history is unknown. Nearly everything that has been learned about axolotls comes from specimens in tanks. The only way to save and study the wild axolotl, Dr. Zambrano and his colleagues determined, was to promote a renaissance of ancestral farming practices and then convert segments of the farmers' canals into axolotl sanctuaries, with the hope that one day they could be linked together. For more than a decade, Dr. Zambrano and his colleagues have published extensively on the philosophy and logistics of this approach. A major conservation group now backs their efforts, while some of their fellow axolotl researchers find them to be borderline quixotic. Now Dr. Zambrano and his team have put their ideas to the test with the release of a small number of animals, 12 to be exact. How's the oxygen? Axolotls must be kept cool, and Dr. Zambrano's lab at UNAM, home to a breeding colony of about 150 animals from wild bloodlines, is maintained at 64 degrees Fahrenheit. On a mid-October morning, with his colleague Carlos Sumano navigating, Dr. Zambrano and a cadre of students set out in a flat canal boat with 6 lab-reared animals in coolers. All were spry yearlings. Under the right conditions, axolotls can live to age 20. In 2017, Dr. Zambrano's group radio tagged 10 axolotls and released them into an artificial lake on the UNAM campus. They saw that the amphibians, not thought to be especially social, often got together in the afternoons for an hour or so and then dispersed. They observed a male and a female that never strayed more than a few feet apart. They also saw one end up in the stomach of a water snake. But the animals gained weight, they had no issue finding food. The axolotls on that October day would be released in submersible cages of bamboo and shrimp netting, allowing them to move around and hunt without being preyed on. The cages would go into canals fitted with biofilters made of volcanic rock and native plants to keep out pollutants and invasive fish. Each canal had to be cool and oxygenated and had to contain plenty of tiny crustaceans for the axolotls to eat. Just 6 animals were being released into 2 canals. In a week, the group would release another 6. Even thinking about reproduction was too much for now. The animals were being segregated by sex. It was enough if they survived. Mara Hutzel, a doctoral student at Metropolitan Autonomous University in Xochimilco, was working on a study that piggybacked on Dr. Zambrano's and his colleagues' conservation effort. She planned to retrieve the axolotls monthly and swab their skins for bacteria, fungi, viruses, all the eukaryotes and prokaryotes that have important functions in nutrition, osmoregulation, nutrition and defense, she said. With most of the world's axolotls reared in fish tanks, no one really knew what their natural microbiota consisted of. Yet they seemed to resist the infectious chytrid fungus which has wreaked havoc on amphibian populations worldwide. What other secrets would the skin swabs reveal? With the boat tied up, the students moved ashore at their first chinampa, a bustling vegetable farm with rows of sunflowers, corn, greens and tomatoes. Javier Del Valle, a co-owner and a 4th-generation chinampero, watched as Dr. Zambrano and Mr. Sumano dug a ledge into the black soils of his canal's banks and began sinking one of their unwieldy, 6-foot-tall bamboo cages into it. The students dipped their instruments to measure dissolved oxygen, turbidity and conductivity. "How's the oxygen?" Dr. Zambrano wanted to know. A Xochimilco native, Mr. Del Valle had grown up eating axolotls, mostly in the form of tlapiques, tamales combining fish, amphibians and vegetables from the chinampas. Unlike many of his neighbors, who have converted their plots to other uses, he believes in the virtues of traditional chinampa farming, which uses no chemical pesticides or fertilizers. He and his family grow 80 varieties of flowers and vegetables on their chinampa, including a rare red spinach that he plucked for the team to sample. His axolotl refuge, at first glance little more than a ditch, had taken 5 years to set up. The UNAM researchers supplied a 70-page manual to interested farmers that described how the canals should be built. "These are small steps, right?" said Mr. Del Valle, a Nahuatl speaker who can recite the harvest festival dates for every crop. But it is a very titanic task. To him, conserving axolotls on his chinampa was part of a more ambitious goal. "It's about returning to a certain knowledge, a certain time," he said. Chinampan roes like Javier are an endangered species, too, said Ms. Hutzel, the doctoral student. By noon, the researchers finally had their cage stabilized in the canal, ready for the animals. The canal's oxygen levels weren't great, but Dr. Zambrano decided it didn't matter. It was important to know whether axolotls could survive in suboptimal conditions, so long as predators and toxins were kept at bay. An advantage of placing only a few animals into isolated canals was that it allowed for failure here and there. Risking too many animals at once was reckless. Only last year, local politicians released 200 captive raised axolotls into a polluted canal, for a media stunt that most likely ended with all of them dying. The students removed 3 wriggling females from bags in the coolers and then lowered them into their new, semi-wild home. They sealed the top of the cage, which poked above the surface. Dr. Zambrano stood staring at it for a while without speaking. "That's it," he said nervously, to no one in particular. Preserving chinampas. Officially, the Mexican government has long agreed that this habitat should be conserved. The Xochimilco wetlands were designated a UNESCO World Heritage Site in 1987. 5 years later, the entire system was designated a protected natural area. None of it has kept axolotl numbers from plummeting. Legally, no houses or permanent structures can be built on chinampas. Farmers like Javier Del Valle commute to them by canoe. Yet everyday boats can be seen carrying building materials. Internal migration puts pressure on any cheap land with access to Mexico City, with which Xochimilco is ever more integrated. In 2020, builders began filling part of its wetlands for a new highway bridge, prompting a lawsuit and fierce protests by environmentalists. The bridge went up anyway, and Dr. Zambrano described the episode as one of the rare moments over the past 20 years in which had he considered throwing in the towel. "I mean, it was our own government doing this to us," he said. Another group of axolotl researchers in Xochimilco maintains a breeding colony, derived from 3 dozen wild indiv What it takes to save the axolotl. On the outskirts of Mexico City, biologists are working to reintroduce a treasure